342, which is intermediate metal conduit. Now, this is going to be a listed sealed circular raceway that can be threaded with integral or associated couplings. Article 342 is intermediate metal conduit. Article 344 is rigid metal conduit. They are both exactly the same as it relates to the code. The only difference is that they're physically constructed slightly different. IMC has the exact same external diameter as rigid metal conduit, but the internal diameter is going to be larger because the wall thickness of IMC is going to be thinner. IMC is actually stronger than rigid metal conduit, meaning that if you try to bend IMC compared to rigid metal conduit, it's a lot more difficult because I don't know what you call that kind of strength, tension, whatever you want to call that there. When IMC first came out, it caused problems with the cutting dies because it just really prematurely reduced the cutting dies when you try to thread it. It also caused problems with the shoe benders when Greenlee and anybody else had these hydraulic benders. Also, you take a half-inch IMC, you take a half-inch rigid conduit bender, you destroyed your rigid conduit bender because it opened up, what do you call that? When you put a bender on a raceway, the
shoe,
the shoe, I guess. So when you try to put it right on there, and then you go to bend it, it did what? It flexed it out. It opened it up. So we had to get new benders. Once you get IMC, it's totally different. So now today, when you buy a bender, it's fine. It's designed for IMC. It's not going to be flexing like it did. So I can't even see any reason why anybody would use rigid metal conduit. But if you did use rigid metal conduit, all the rules we're talking for IMC applies to rigid metal conduit. I'm just going to focus on IMC because I think it's a great wiring method, and why not focus on it versus rigid? So we're not covering 344 in this presentation, but of course it's in the textbook. I'm just going to jump to 342. I'm not going into uses permitted and uses not permitted because rigid conduit and IMC can be used everywhere. And not permitted is, kind of obvious. You can't put it where corrosion and those kind of things. So I'm just jumping into bending radius 342.24. Raceway bends cannot be made in any manner that would damage the raceway or significantly change its internal diameter. This rule about bending and .24 on all the metal raceways have the same thing. So I'm not going to be saying this and reviewing this on all the other raceways. And so a lot of these rules are repetitive as we go along, and I'm just going to quickly run through. What it's saying is that you cannot kink the raceway. You use the proper tool, you should be fine. 342.26, number of bends. The rule is no more than 360 degrees between pull points. It actually says 4. I think it says 4 quarter bends. Ryan, if you can read to me exactly 342.26, does it say quarter bends, or does it just simply say the maximum total number of bends between pull points shall not exceed 360?
Well, it says both. It says there shall not be more than the equivalent of 4 quarter bends. Then parenthetically, it says 360 degrees total.
Equivalent of 4 quarter bends. Well, take a look at this graphic here. I mean, you do an offset, a 15-degree offset. Well, that's 15 and 15. That's 30 degrees, and then 90 and 90, and then another 30 degrees here. In this case here, we have, 90, 180, 210, 240. So you simply add up all the bends. Now, questions come up sometimes. Well, what's the maximum distance you can go between pull boxes? I just got a guy ask me a question. Hey, I got these 2 boxes that are 360 feet apart. Is that okay? Sure. Yeah. Doesn't matter how far apart. The key is this: no more than 360 degrees of bends. So pulling a wire long distance, that's not a problem at all. It's just a matter of getting the right size conductors, right lubricants, the raceway size and conductor fill. There are calculators out there in case you had a concern about friction. But we'll talk about that at another time. Unless, Ryan, you want to say something?
Well, not about this. Are you done with that?
No, I'm done with that.
Okay. You were mentioning the corrosion thing, and this is a question I get asked quite a lot, so I figured let's hit it. First of all, there is no .12 in rigid or IMC. There are no uses not permitted. You can use this literally for anything in the code. But regarding the corrosion, this is in the UL White book that I'm reading, and it's the same for rigid. Galvanized IMC installed in contact with soil does not generally require supplementary corrosion protection. I don't need to tape my rigid metal conduit. And then it says, In the absence of specific local experience, soils producing severe corrosive effects might. But generally speaking, if you're in dirt, you do not need to tape it.
You know, and they do make PVC coated conduit. I don't know if sure it's rigid or IMC, but they make PVC coated. So if you have a, you know, there's a possibility rigid conduit, the metal, steel is not suitable for that environment, well then you can get coated conduit. Victor, do you guys ever spec any PVC coated rigid conduit?
I used to. I've had bad experience with it.
Yeah.
You get little pinpoints in that PVC coating, and it becomes an attack point, and the corrosion will actually increase. It's worse than if you had the whole thing undone.
Now that, but once you cut it and thread it,
Yeah, exactly. And those little points like that become real damaging corrosion points there. So I hate to say it, but I wouldn't recommend PVC coated rigid in most applications.
wow. Eric, you had some experience?
Yeah,
on
I
that?
had a lot of experience with PVC coated conduit, and the basic bottom line is if you can install it absolutely perfectly according to all instructions with all the right tools and waiting all the proper times, it might work.
Then you're saying you don't want to have it done by a guy.
I've actually seen what was a PVC coated conduit once. I'm looking at it, and it's sagging, and when we looked into it, there was a line of rust inside the PVC.
Yeah.
The metal was all eaten up.
I've actually gone out on a job site where I put the conduit in, and a year later go back in and I can squeeze it.
Oh my God. Okay, well, I'm sure those guys that are making PVC coated conduit are not happy about this DVD. Maybe they'll never know. Let's take a look at 342.28 reaming. All raceways, all the metal raceways are the same thing. When the raceway is cut in the field, reaming is required to remove the burrs and rough edges. They make a specific tool for the purposes that when you cut the conduit that you ream it. 342.30, secured and supported. You have to secure the raceway within 3 feet of termination. Okay. Now, years ago, it used to say within 3 feet of fittings. And so some guys were thinking you had to have the support within 3 feet of couplings. That's been clarified over the years. So it's 3 feet of the termination. You might terminate in an LB, well, then you need 3 feet of that termination. Or in a box here within 3 feet of termination. Okay, let's take a look at 342.30A2. The rule is you need to support it within 3 feet of termination, but not if the termination is not available within 3 feet. Then you can go up to 5 feet, and the couplings between that point of termination and support is not relevant, so it's fine. Now, one is securing within termination, and now is supporting it. And there's a table, 344.30B2, which tells us how far apart we can support conduit. Ryan, take a look at the rule. Is the rule saying that you have to support rigid conduit every 10 feet except as permitted in the table, or does the code just say you support it per the table?
The distance between supports for straight runs of conduit shall be permitted in accordance with the table.
Okay, so
if you're using threaded couplings.
Oh, okay. So if we're not using threaded couplings, the rule is what?
10 feet.
10 feet.
Right.
But if we're running straight runs and we're using threaded couplings,
Yeah.
then I go to the table, and if this was 1 inch, let's say, rigid conduit,
Yeah.
well, 1 inch conduit can be supported per the table of 12 feet.
Right.
Vertical risers, you can go up to 12 feet between the points of support. Couplings and connectors, 342.42, couplings and connectors. Where installed in wet location fittings must be listed for use in wet locations. Now, if I put a raceway in the earth, Ryan, you say that rule was 300.5B?
Yes.
That raceways underground are considered to be in a No, no, no. No, that one has to do with the interior of a raceway. The
Correct.
rule about wet location in the ground is Article 100.
That's, yeah, the definition of location, comma,
Yeah, so,
location,
so,
comma, wet.
so if I put a raceway in the ground, it is a wet location. And if I
Agreed.
put a raceway in the ground, that is a wet location, then the interior of that raceway is considered to be a wet location per 300.5b.
Yes.
Running threads. I don't think this is something many people are aware of or have seen this. I don't know if you've even seen this or not. A running thread is when you take actually, you can buy these. You can buy a running thread. In other words, you can take a lock nut. You can take a lock nut and you can thread it all the way through till it comes off the other end. Because normally when you have a nipple, you have threads that are going to be in one direction going this direction, of course, and then threads going this direction, so that you couldn't take a lock nut all the way through because it stops at that center point because the threads are going, I don't know what you call that. And so the other way is it just goes all the way through. So now you'd use a nipple between enclosures, which would be great, but you got to put one enclosure. Then you have to put the lock nut outside and the lock nut inside. Let's say you're doing that way, and then you're bushing. Well, then you put another lock nut. Then you put the enclosure on there. Then you put your lock nut and you're bushing, and you get your conductors. Well, the problem is if you already have two conductors next to each other, two enclosures already next to each other, you can't get a nipple in between the two of those. So what you get is what is called a running thread. You punch it 2 holes, then you just start getting a lock nut on one side, and you can do the mechanics, put a lock nut in the center, to get another lock nut on the other side, to get a lock nut on the other side, and you got to keep playing with all these lock nuts, and therefore you can get a raceway between 2 fixed enclosures. Brian, have you ever used a running thread?
Yeah, we actually stopped using those everywhere we can possibly stop using them, and we've gone to PVC and box adapters because it's just a lot easier to deal with. You don't have to thread anything, but yeah, we used them for years.
You cut a piece of PVC, you slide it between the 2 fixed enclosures.
Yep.
Then you get the box adapters, which is like a coupling.
Yeah, you usually just
basically.
use a coupling is the easiest thing to do.
Coupling.
Yep.
Oh, you can, okay, and then you put the box adapters inside there. Ryan, have you seen much running threads at all in your career?
Yeah, you see them. Not very often. We always heard them. I've always heard them called close nipples.
Close
I don't know.
nipples.
Yeah, that's not a
Close
use on
nipples
thing.
similar.
No,
it's not
close
running
nipples-
Oh, it's not the same thing.
Yeah, it's not the same thing.
Oh, okay.
No.
Yeah, close
But yeah,
nipples,
I see these. Maybe I just called them the wrong
It's
thing.
a thread that goes all the way to the same thing. A
Yeah,
close
right.
nipple
A close
would be.
nipple you can only go
Oh, you're right. It
halfway.
has you're right. Yeah.
Has
You're
that center
right. But
point.
yeah, I see those, but yeah, not very
It's only
often.
when you need to get it between 2 fixed enclosures.
Yep.
Right.
You wouldn't want to use a running thread because you
Right.
get a close nipple.
Right. Yeah, exactly.
Victor, how about yourself?
Yeah, I've used them, but as you say, it's only when you need to.
Okay.
Get,
But now watch what the code says. The code says running threads are not permitted for the connection of couplings. But they are permitted other locations. The reason you can't put a coupling, because if you put a coupling on there, you can thread the coupling till it goes off the other side. In other words, the purpose of a raceway is that as it has a taper, 3/4 inch per foot, that as the thread goes into a fitting or a coupling, it starts to bind that. Or if you have a running thread and the thread is just straight across, there's no taper, well then you could never get a bond, a solid effective ground fault current path between the two. And that's the reason why you can't use them at couplings, but you could at other locations. 342.46 bushings. We talked about that in 300.4G. For all practical purposes, anytime it's a threaded raceway entry, then you are going to have a bushing. Now, if you go into a hub, well, then it's automatically protected. It's not a problem. Anytime you have connectors, then it's 4 gauge and larger, you would need to have a bushing, and 6 gauge and smaller, you do not. Ryan?
People get really confused on this, so I think it's worth kind of saying what the code says. It says where a conduit enters a box, fitting, or other enclosure, a bushing shall be provided. But when does a conduit actually enter a box? The only time the conduit enters the box is on the left.
That's right.
The other ones, it's a fitting that enters the box.
Right.
And
You're
that's
saying
where people get
you're
really
saying some
screwed
guys
up.
think
Yeah.
that rigid conduit.
I say, yeah, well, the conduit entered the box. No, it didn't. The connector entered the box.
Oh.
On the left, the conduit entered the box.
So we probably need to clarify the conduit enters box right here, right? Well, then
Good,
you
yeah.
need always to have what? You need a bushing.
Right.
These are connectors entering the box. Well, then you comply with 300.4G requirements
Right.
when a connector enters the box.
Right.
Okay, good point.